Welcome to an example in which we are looking at graphs of limits of functions. So we're going to do three examples. So this one, first off, they're asking us right here, what is the limit as x goes to 2 from the left? So let me make sure you're clear on that. This right here, when they have that minus sign above the 2, that means, let me say it better. That means x goes to 2 from the left. So the negative means from the left. And then down here, when it says x goes to 2, um, that plus sign means from the right side of 2, from the right of 2. And this one here means from the left of 2. So, for example, here's the x-axis. Don't confuse the x-axis with the y. The sideways one, this here is the x-axis, right? The vertical is the y. So here's the x-axis. And we mean as you're going along the x-axis, here's 2, from the left of 2. So in other words, you're coming this way. So that means on the graph in particular, you're coming this way. You're coming from the left. So if you're coming from the left of 2, if you're going towards 2 on the x-axis, but you're coming from the left, that's what 2 with the minus sign up there means, coming from the left. What does it look like f of x is? Now remember, f of x is y. Y or f of x, there are two ways of saying the same thing. Function values are always y values. So if it says g of x or h of x or any function, that's the same thing as y. So you just need to know that about math language. Function values are y values. So when it says, what is the limit as x goes to 2 from the left? That minus is not a negative 2, right? If the minus was in front of the 2, that would be a negative 2. But the minus is like a power. It's in the upper right-hand corner. That means from the left of 2. As x goes to 2 from the left side on the graph, what is the f of x? What is the y? In other words, what is the height? Well, the height is about negative 2. That's why the answer is negative 2 there, right? As you're coming to this point, you're coming to 2. What does it look like your height is coming close to? Negative 2. Let's try this right here. What if you go to 2 from the right? So that's coming this way. And again, it looks like you're coming to a height of negative 2. You might think, aren't they always going to be the same? No. No, let's go over and look at the other graph for a minute, and you'll see what I mean. This one is going to negative 1 from the left. See how it's got a negative, make this bigger. It's got a negative in front of the 1, so it's a negative 1, and then it's got a negative in the upper right-hand corner, which means from the left. So negative 1 with a negative 1 up there. That means to negative 1, and the negative 1 in the power means from the left. So it means we're coming, here's negative 1 on the x-axis. We're coming this way. And what is the height? What is the y value we're getting close to? Well, 1, height of 1. Whereas if we're coming from the right, this is negative 1 with a plus up there means to negative 1 from the right side of negative 1. That means you're coming this way. It looks like your y value is about 3. See how as you approach this line right here at x is negative 1, this is the x equals negative 1 line. And as you approach that line from the left side, looks like you're coming in at a height of 1. But as you approach that line from the right side, looks like you're coming at it at a height of 3. That's what we're talking about. The limit, as you get really close to negative 1 from the left side of negative 1, is you're going to an x value on the x-axis of negative 1. As you come from the left side, it looks like your height, your f of x, your y, is coming in at a height of 1. But as you come from the right side to hit x is negative 1, you're coming in at a height, the y value, function value of 3. So that's the difference. So notice on this graph, as you get close to negative 1 from the left and the right, they're hitting at different heights, aren't they? Whereas on this graph right here, from the left and from the right are hitting at the same height. Well, that's the crucial issue. When, whoops, to be a different color there. Thought I had it. Try that again. When hit the same, well, listen. When they hit at different heights, when the left and the right, let me see. Oops, I'm in a little trouble. When the left and the right side of the same x value are different heights, or y values, then the limit d in e at that x value. D and E stands for does not exist. So this one over here, that's why this one is D and E. You see? Because from the left side and the right side of the x value -1, it's hitting at different heights. This one's hitting at a height of 3, this one's hitting at a height of 1. They're not going to meet. Whereas over here, you see, the left side and the right side of x is 2 are both hitting at the same height of -2. So this one is an answer of -2. So when the left side and the right side answers are the same, then that's the limit at that point. So a graph can have a limit from the left side only, like this one has a limit from the left of -1. Oops. Right? This one has a limit as you come from the left of -1, height of 1. You come from the right of x is -1, height of 3. Different answers. So the overall limit, see, this is the overall limit right here. The limit, I'll just put the words, the overall limit, which is right there. Because it doesn't, what I mean by overall, it doesn't say from the left or from the right. It says the limit as you go to -1, just overall, not left or right. So that's D and E when they come in at different heights. Whereas, let me add to this, when from the left and right hand limits, heights, limits hit the same height, let's put it that way, when they hit the same height, then the overall limit as x goes to that value is the same number. Is that same number, I should say. And that's what happened there. You see the difference, right? And so in this one, from the left side and from the right side, they're both hitting at the same height, -2. So that is the overall. This again, this is an overall question. Whereas this first one's just left side, right side, overall. Left side, right side, overall. All right. Now the final question they're asking is they're saying, hey, what is the actual function value at 2? Change my color there. What's my actual function value to? Meaning just at f of 2. Well, that means where's the solid dot? So f of 2, whenever they just give you like f of x equals the height of the solid dot or solid graph at that x value. Because remember, f of x is always a height. Function values are y values. They're heights. So when it says, what is f of 2? It's saying at x is 2, what is the height of the function? Well, there it is. It's up at a height of 3. That's why the answer is 3. Solid. I think might think, well, yeah, what about all this stuff down here? Well, there's an open dot right there. So the function doesn't actually hit a height of -2. That is the limit. That's what it looks like it's headed to from the left and the right. But in actuality, the function at 2 is up at 3. How about over here? What's the function on this one at -1? It's way up here at 4. At -1, the function's way up there at 4. So it's where the solid dot is. Let's look down here at another example. How about this one? So we're talking about going to 4 from the left. Here's 4. Should come to 4 from the left. What is your height? You're coming in at a height of 2. And then when you come to 4 from the right, see the plus sign here? From the right. Should come to 4 from the right, coming in at the same height, height of 2. Okay, so since they're the same, then the overall limit as you go to 4. The left and the right are the same, then that is the overall limit. But, final question, what about f of 4? Well, it doesn't exist. It's D and E. It does not exist because there's no solid dot. See that here at 4? There's no, if there was like a solid dot up here or a solid dot down there or something like that, then that would be the height. But all we have here is an open dot. At x equals 4, there's no solid dot. There's no solid function. The function doesn't exist, actually. There's a limit there, but there's not a function value there. It's only, or it's not, let's just say it's not a solid dot. Whoops. It's not a solid dot. Not, oops, I'm just scribbling. It's not a solid dot. It's open. It's an open dot, which means it doesn't really exist. An open dot on a graph means a hole in the graph. The graph doesn't actually take on that value. It doesn't actually exist there. And so there we go. There's how we do limits with graphs. Okay, so on this question, we're going to do something with this little function. And there we go.